嗨，同学要记得去留言哦。那我们就继续上课喽。好，昨天上到面积分。Okay, last time we have talked about the surface integral, and this is the equation for calculating surface integral. I think we have a example before we dismiss the class, right? So yesterday we end at this example. Let me show you another example. Okay, so let's go to slide 50. Example 12.21. Okay, evaluate this surface integral. This surface integral. So you can find it is surface integral. So you have first find the function for the integral function z. So the function is only z, and the target is sigma, right? Sigma. And like the line integral, if you are calculating line integral, you should find a target for a line for single integral. But this is a surface integral, so you find a double integral for sigma. Then the example should give you the condition for sigma. So sigma is a plane, and the equation for this plane is this. This one is the equation for sigma. Also, the range for x and y. So you can find in this example there is no uv. If the example talking about uv, this is a more complicated example. So only x, y, and you can find from this equation. Z can be represented by x, y, right? If you move x and y to the right hand side, you can get function of z using x, y. So it is a more is an easier one. Then please see this figure. Actually, sigma is a little complicated. The plane is, this equation shows the plane, the triangle. Okay, triangle, this one. The plane is this one. Okay, lying above the rectangle. Lying above D. D is this one. The range of D is x from 0 to 2, y from 0 to 1. So the range is this one. But sigma is this one, okay? Sigma is this one. Sigma is the plane, triangle, this one. The plane lying above the rectangle D. So this plane lying above the blue region. So it is this one. Okay, so sigma is this one. Let's do the surface integral. Okay, so you can check the equation again I put here. It is the surface integral, right? The f is the function, and the sigma is the target of the surface. You can change sigma d sigma into d dx dy by using this kind of conversion. So this equation, we want to use it now. Partial x means partial z. Okay, z can be S of x, y, no common here. Okay, again, no common here. Z is S of x, y. Z can be function of x and y, so you can use the equation here. So first, please try to have a S of x, y. So just move x, y to the right hand side as I mentioned before, right? The equation is like this, but we want z is equal to something, so z is equal to this one. Then we can directly do this. Okay, so by checking this, this is the problem, right? This is the example. So sigma this sigma, try to convert it into d dx dy, d dx dy. Dx dy is the same as dy dx. They are the same. So z still here, and this part is this part. This square root is this square root. So partial s, partial x, partial s, partial x is -1. Very simple. Partial x, partial y is also -1. Very simple. So you can just calculate it as square root of 3. And the z is z. So replace z using xy here. Okay. Then the range y is from 0 to 1, x from 0 to 2, as shown in the problem. Okay. So it is very simple. Okay. Then how to calculate this double integral? You have to calculate it step by step. So first, do it using dy. First, compute this one. Okay, inside. So this one, you consider x as a constant. It is dy, so x is constant here. So 4 minus x is a constant. So just put a y here. And a y is integral of y is this. Okay, and put a 0 to 1 inside, you can get this answer. Then compute the final answer. You put this answer here, right? Like here. The final answer, put here, and you get this. Then do the calculation, and you can get a final answer. You can compare this example as the last example we talked about. Yesterday. You will find this example is much simpler because the equation you can use x and y to represent z. No uv, only xy. The example would be much easier. So that's why I suggest you to memorize this equation also. Okay. Don't just memorize the general one. General one with UV is more difficult. But this one, if you can have this kind of equation, z is equal to some x and some y. If you can have this kind of equation, using this formula will be much easier. Any question? Okay, can I go to the next topic? Okay, then it is we still have we still have two theory in chapter 12. At least two theory is difficult. Okay, so first, I think today, okay, let me show you the first one. First one, we lifting green theory to three-dimensional space. Okay, so now I'm deriving this equation. So recall the green theory. This is a circle. Okay, this is circle, and this is a circle. Okay, so this is the green theory. You can see, if you remember, green theory is to convert single integral to double integral. Single integral to double integral. So it is one-dimensional integral to two-dimensional integral. But if we want to lifting the green theory to three-dimensional space, that means the green theory should be 2 to 3. Okay? A new formula is to convert two double integral to triple integral. So how to have the formula? First, we define a vector field. Okay, so let's have f is equal to gi minus fj. Again, okay, you can put an arrow. You can put an arrow here. Define this one. Okay, we just want to have a equation like green theory. Then do this. You know this one. This one is equal to, this one is a vector. It's partial, sorry. It is partial x, partial y, if it is in the two-dimensional space. Yeah. Partial x, partial y, partial x, partial y. Maybe you will see this at many spaces later. Okay, this one is partial x, partial y, is a vector. This one, okay, this one is this one, partial x, partial y, vector. So if you do the dot product, right, it is a dot product of this one and this one, you will have this one. Okay, so first we defined f. Then we define another thing. Let me tell you the name for this one. This symbol is called a del. It's called a del. Okay, del, del, del. So this is del f. Del f is this one. Then we want to have a parametric equation for C by using the arc length. So you can see this figure, and this is the curve C. We can define the C using x of s and y of s. and the range of S is 0 to L. So if this curve is C, then try to find the tangent vector. Okay, tangent vector, how to find the tangent vector? It's very easy, just to the differential of x and differential of y. You can have a tangent vector. Then what is the normal vector? You know, if the tangent vector is like this, if you want to find a vector normal to the tangent vector, you just change the sequence and put a minus here. I hope you learned this before, okay? So the way to find the tangent vector is this one, right? Tangent vector is this one. If you want to find the one vertical to the tangent vector, if you want to find the n, you just have to change the sequence, change this part and this part, and also put this as minus. This is a way to find the normal vector to certain vector. Normal vector to tangent vector. Okay. Then this normal point outward from D, it is the unit outer normal vector. Maybe you can put a vector here. We want to find a unit outer normal vector. Unit outer normal vector. Let me ignore. Okay. Okay. Then, if you have this unit outer normal vector n, you do the dot product of f and n, you will have this. We are trying to have some equations similar to green theory. You will know what I'm doing later. So this one is this one, right? And this one is this one minus. So do you remember what is f? You remember, right? F is g minus f. Okay. F is g minus f. So dot product with n, you will get this. This is the second thing we want. Be careful of the unit outer normal vector. It should be unit. The length should be 1. Okay. Let me go to the next slide. So you can find one thing. Okay. This is the circle. Okay. This is the equation for green theory. This is circle. Equation for green theory, right? Green theory, the left hand side, green theory. And green theory, okay. And you put a ds. Okay. Then if you remember, you can see your last slide. If you remember, this one is this one, right? We just write that. Okay. So this one is the left-hand side of green theory. The single integral of green theory. Then you will find the left-hand side of green theory, and this is the right-hand side of green theory. If you remember this one, to remember what is this one. The first point, right? The first point. Let me see. Here. Okay, here. LF is this one. This one is this one, right? So you can put this one here. Then you will get this. Okay. So the green theory, we convert green theory in different form. This is still green theory. Okay, still green theory, but in different form. Okay, so let's observe this green theory. This is 1 to 2, single integral to double integral. So now, how to lift the green theory to 3 dimensions? First, we want to lift one single integral to double integral. So using the first part. So replace the closed curve C to closed surface sigma. Okay, closed curve is the one-dimensional curve. You replace this using closed surface. Closed surface is two-dimensional. And the curve is in a plane. The surface is in 3D space. Okay. So it's like it's in 3D space like to bounding a volume like sphere. So let me explain more. For the closed curve C in a plane, it's like a closed curve C, right? Curve C. And if you have a closed curve C, you will have a area inside. Okay. But if you, it's hard to draw. If you have closed surface maybe it's like a cube. I'm drawing a cube, but maybe you don't know what I'm doing. Okay, it is a cube. So this one is one of the surface. The another surface, 6 surfaces. You will bound a volume such as a cube here. Sphere is hard to represent here, so like a cube. Okay, so the first thing, this is the single integral. You have a closed curve C. You lift this part to double integral, so you want to use a closed surface sigma. So for the closed curve C, you will bound the area. For closed surface sigma, you will bound the volume. Okay, this is the first thing. Second, replace the line integral over C. Replace line integral over C with a surface integral over sigma. It's like a single to double integral. And allow the vector field to be a function of 3 variables. So from 2 variables to 3 variables. So let's see how to change. Okay. So maybe we can have at least one to compare. Okay. Okay, just compare. This is the green theory, different form of green theory. So this is the closed curve C. You lift it into closed surface sigma. So single integral to double integral, okay? And for this part, it is area, integral over area, two-dimensional area. You leave it into three-dimensional volume, three-dimensional, okay? That's it. Please memorize this. This is called the Gauss divergence theory, 高斯散度定律 Gauss's divergence theory. Okay. So please memorize this equation. I will not give you when you taking exam. Please memorize this equation. Okay. And there are some explanation here. M is the solid region bounded by sigma. Okay, M. So like I mentioned, if we talking about a cube is bounded by 6 surfaces, right? Cube. So M is the solid region by sigma. The sigma is like the plane, the sixth plane. M is like the cube. Okay. Also, another thing important, N is important and N is hard to calculate. The most difficult part to calculate is N. Okay, N is a unit normal vector, and is normal to sigma, and point out of surface away from M. So N, let me show you again. Where is N? Here, unit outer normal vector. You will know this when I'm talking about example. Remember, unit outer normal, three things. Unit outer normal, okay? Unit outer normal, unit outer normal, okay? Normal to sigma. Okay, so here is another way to verify the equation, verify the Gauss's divergence theory. I want to skip this. Okay, just another way. Let's go to slide 59. So the divergence theory of Gauss. The same as I told you. Green theory lift the green theory to Gauss divergence theory. Okay. So from green theory to three dimensions, we have divergence theory. So the divergence theory of Gauss, or Gauss's divergence theory. The formula, the equations here, please memorize here. So let's see. First, sigma. Sigma is a piecewise smooth closed surface. First, sigma is piecewise smooth closed surface. Second, M. M is bounded by sigma. M is bounded by sigma. Okay. Then what is N? N is unit outer normal vector. Unit outer normal vector. And its outer way is from sigma. Relating to sigma, N is a unit outer normal vector. Okay, then what is F? F is a vector field and it is continuous. Continuous no matter at first or second partial derivatives. So F is continuous everywhere. That is a definition. The most difficult thing to calculate is outer normal vector. Unit outer normal vector. N is the most difficult part. So maybe you can deal with this at first every time. That's the one example. Okay. For this example, okay, let us see this slowly. Sigma first. Sigma is a piecewise smooth surface. Okay, piecewise smooth surface. And what is sigma? Sigma is consisting of sigma 1 and sigma 2. Okay, piecewise there are two pieces. Sigma 1 and sigma 2. First, let's see the sigma 1. Sigma 1 is a cone. The equation of cone is like this, and the range is like this. Okay, let's first see this equation. If you put the order of 2 here, you will get what? You will get z squared equal to x, y, right? You will get thing like this, right? If you put the square at both sides, you will have this one. Okay, please know this. This one is the cone. This one is a cone. Okay, why? How to see this? This one is a cone. You can see at here, z is equal to 0, right? Equal to 0. So x squared 8y squared is also equal to 0. So this point is 0, 0, 0. Okay. So maybe here. Here is like z is equal to 0.5. Okay. 0.5. That means x squared 8y squared is equal to 0.5, right? So it is a circle. It is a circle with the radius is equal to square root of 0.5, right? Okay. So at a plane z equal to 0, it is only a point 0, 0, 0. At a plane z equal to 0.5, it is a circle. The radius is square root of 0.5. So here, z is equal to 1. You can find x squared, y squared is equal to 1, right? And the radius is 1. So the circle is larger and larger. Circle become larger and larger when z become larger. The circle, they are all circle because x squared 8y squared. X squared plus y squared. So at every plane of z, they are circle, but the radius become larger. Radius become larger when z is larger because the radius is z. So that is cone. Please remember, this equation means a cone. The shape is cone. Okay? Then for this equation without square, okay, without square, for the equation mentioned in this example, without square, okay, you can see the square root means it's larger than 0, right? Larger than 0 because it is a square root. So you can see only the shape is this one, larger than 0. Okay. And for this one, smaller and equal to 1, so stop at z equal to 0. So this one is sigma 1. I will not give you the figure. I will not give you the figure when you take an exam. So you have to know what is the figure of this equation. And the example tell you it is a cone, but how to draw a cone like this. Okay, and then that's the other plane, sigma 2. Sigma 2 is the flat cape. It's a cape. Okay, cape. Consisting of the disk. The equation is this. In the plane, disk is equal to 1. Z is equal to 1, and the disk is like this. So the blue part is the figure for sigma 2. Okay. If we change this equation, I think you know this equation, x squared plus y squared is equal to 1. What is this? This is a circle, right? Circle means only the outer curve. It is circle because this is equal to 1. Equal to 1 means it is a circle. But this is smaller and equal to 1. So that means inside the circle and on the circle. Okay? Equal sign means circle. Smaller than 1 means inside. Okay, I think you can understand this figure. So this part, right? This part, 3 lines. 3 lines tell you the condition of sigma. Then this is the condition of f. Very simple. It is a function x, y, z. Then calculate both sides of the divergence theory. Let's calculate the most difficult part first. A unit outer normal vector. Okay. Then I have take this for you. This one is a normal vector at P0. I have taught you before. Normal vector at P0, and this is a simple form, right? A simpler form with by using, if you can have z as a function of xy, you can have this form. So first, okay, in my handout, I just directly give you the answer. So let me show you how to calculate. First, you have to know. Now we are talking about sigma 1. Okay, sigma 1. So what is z? Do you remember? Z is, you can check. You can check from the problem. Okay. Z is this one. So just calculate. You can calculate now. I'm waiting for you. Z is square root of x squared plus y squared. Please do it. Okay. Partial z, partial x, and a partial z, partial y. Please do this. Partial z, partial x. You have the 1/2 order, right? And inside you will have minus 1/2. And you have to do the differential for x squared again. So 2x here, right? So the final, then you have to know this one. What is this one? This one is equal to 1 minus 1 over z, right? Z is this one. So this one is 1 over z. So the final answer, delete 2. Final answer is x over z. Okay, here. You can do the same thing for y. So I don't want to have this again. Okay. And also k is 1. So first thing first, this is our unit outer normal, right? Unit outer normal. So let's do unit and the outer in sequence. So first, if you are using the method I provide to you, first you will get n is equal to x over z, y over z, and 1, right? See this one. A minus here. Okay. If you are using this way, partial z partial x is x over z, and put the minus here. The same thing, you can have this one, and the k, the coefficient for k is 1. So first you get this. Secondly, let me show you maybe unit. Okay, let's put it as unit vector. So maybe we use a small n to represent a unit. So first you have to know the length, right? The length of n. Length of n is square root of x squared z squared. Oh, it's very hard to write it using this way. Y squared z squared, okay, and 1. Oh, okay, and these two, x squared over z squared, 8 y squared over z squared. This one is equal to 1, okay, because z is equal to the square root of this one, so z squared is y squared plus x squared plus y squared. So this one is 1. Try to understand by yourself, please. So this one is 1. So that means the length of n is equal to square root of 2. Okay. No space. I would like to remove something. Okay, so you know the length of n, so you can have a unit vector. So before writing the unit vector, let me show you the outer. How to see the outer? It's a little hard. I will explain outer using Chinese. Okay, outer. OK，好，我们解释一下 outer，就是这个向量要朝外。这向量怎么朝外？你看这个 sigma one，sigma one 是个平面，你要找个朝向它外部的向量。我们先随意画一下吧。这个是一个空，是一个锥体。那我如果用这边画的话，这叫朝外。我现在画的是朝外，这叫朝内，对不对？我们要找一个朝外的。好，我要找一个朝外的向量。你现在就想这个朝外的向量，它有 x、y、z 3个方向嘛？那你想哦，你现在看的这个 equation 最简单的一个方向是谁？是不是 k？k 要么就正一，要么就负一，就 k 是一个 constant 嘛，它要么就正的，要么就负的。那前面的这个 x 跟 y 的，就是 i 跟 j 的方向呢是 x 除以 z 跟 y 除以 z，它比较复杂，但 k 一定是一个常数，对不对？所以说你现在就要判定你到底 k 前面是正一还是负一，你的 outer 到底是正一还是负一。我们回来看这个东西叫 outer， 向外，这叫向内。我要找这一根，请问它看起来是向下还是向上？它向下嘛？如果你比它跟它，我们只要看 z 哦，只要看 z 方向，这个 outer 是向下，这向上，所以我要一个向量，它的 y 是负的，好吗？这个向量 y 是负的，就这样，我解释到这 ，y 是负的，所以说 所以说你今天要的方向不是这个方向，不是这个方向。我的这个 n 是反向，但是我照刚刚的算法，我照刚刚算法就算出这个嘛。但你算出这个之后，还要自己判断，你要判断这个是 outer 还是 inner，你要判断，你要找 outer。所以照我刚刚讲的，如果你希望 y 是负的，你要找 y 是负的才是 outer，所以你要这样写，你要给它一个负号，这才是对的。好吗？所以 outer 是这样做，然后再把长度除掉，长度除掉 ，so you can get this. Okay, this one here, and you want a unit vector, so you have to divide it using square root of 2. So this is the unit outer normal vector to sigma y. This is the most difficult part. Okay, try to know how to have this one. I cannot finish this example today. So, you can write down this. F is xyz. F is xyz. So F dot product of n1 is this one. And this one is 0 because z is equal to this one. You bring z using x and y. Okay, you bring z using x and y. You will find the calculation of this term is equal to 0. Okay, then we can stop here. Then write down this one. Okay. You can do the integral. This is the left-hand side of Gauss divergence theory, left-hand side, but only for sigma 1. Okay, so first you get this one. Sigma 1, the double integral is equal to 0. So we will continue tomorrow. Not tomorrow, next week. Yeah, next week maybe we can do it out of line. Please write down here, and I want to show you the following solution, but I will teach you carefully later. So first, get a sigma 1, then for sigma 2, okay, sigma 2. You don't have to write it. Now. Sigma 2. I just want to show you the process. Sigma 2, then you can get a sigma 2, okay, because it is piecewise smooth. So sigma 1 and sigma 2, then you have the sigma. This is the left-hand side of the divergence theory. Sigma 1 plus sigma 2. Then the right-hand side, this is the right-hand side. Right-hand side, you do the del f, and you do the integral. You will get this one. Okay. So you will find the left-hand side is equal to the right-hand side. I will tell you later. Okay. So you can have this today till here. If I forgot, please remind me. I have not finished this example. Okay, please remind me in the last class. And next week we have no quiz. The quiz is in the week 10. 下周没有小考，我们是下周，因为上周春假放掉，所以我们不是第9周小考。第9周你们可以准备你们的期中考，第10周才会考。第10周的礼拜3考范围是考到第10周的礼拜1上的地方，蛮多的。OK， 没有问题就可以下线，有问题你可以跟我说。谢谢。